Hi, my name is David, and this is an Arduino timer and relay control circuit. It is a simple circuit that consists of Arduino Nano, relay modules, LCD and I2C, push buttons, a buzzer, a power source, and jumper wires, 9-volt battery, and a load. The load here is our LED light here. And they all function in order to allow the user to control the timing of the activation or deactivation of electrical devices, with the Arduino Nano being the centerpiece of this circuit, which is programmed to trigger a relay switch based on the specific time interval that was set using these push buttons right here. Here's what I mean. These are the push buttons we use to control the time input. This first button is the mode button. Now, these two black buttons are the time increase or decrease buttons. This last one is the set button. The mode button helps you switch between SS, which means seconds, which is used to set the amount of seconds you want the timer to run, and MM, which means minutes, which is the amount of minutes you want, and HH, which means hours. Let's test this. I'll set the timer for 10 seconds. The circuit should disconnect the load, which is our LED light, after 10 seconds. You can set this for 30 seconds, 50 minutes, 24 hours, 90 hours, etc. Here is the circuit diagram to this build, so you can make yours as well. Once you're done with all your connections, it's time to program the Arduino Nano and tell it what to do. The link to this circuit diagram, the Arduino library and code, I pasted in the description box. Now let's code. Sorry, I use an old laptop, so I can't read the screen record, so I have to use my phone to record the laptop screen. What I'm highlighting right now is the Arduino library from GitHub for the liquid crystal I2C display. This is the second library, also from GitHub, for the countimer. Now let's talk about the void setup. First thing you see is the serial begin being 9600. What that means is it basically starts serial communication, so the Arduino can send commands through the USB connection. In the loop function, the code checks if a button is pressed. When the button is pressed, digital read is low. Digital write is used to turn on the relay and buzzer. The code then uses delay to wait for the set time delay. Now finally, the code turns off the relay. Now this loop continues running continuously until the board is turned off or reset. One of the applications of an Arduino timer and relay circuit is home automation. There is no difference between the Arduino timer and relay circuit and the device. All I did was just solder components together instead of using breadboard. You can see the Arduino Nano, the LCD I2C screen, the relays, the push buttons, and a 5-volt module to power the Arduino Nano. Other application of an Arduino timer and relay circuit includes in agriculture to control irrigation systems by setting watering, duration, and frequency. In security systems to schedule the activation and deactivation of a security system such as a camera or alarms. Here, the Arduino timer and relay device is connected to a power extension, and the refrigerator is connected to the timer and relay device via a socket. Now I'll set the timer to 5 minutes and 15 seconds, which means the refrigerator will be on for about 5 minutes and 15 seconds. Thereafter, the relay inside the device will trip off, hence switching off the refrigerator after the set time of 5 minutes and 15 seconds.